Alrighty, welcome back to another video. So today we are going to be looking at multiplying algebraic terms. So we looked in the previous video at how we can add and subtract these like terms, and we're going to see the effects of this in regards to just taking another arithmetic operation that we're used to with numbers, and this is multiplication. So it's going to work in a similar way, and we'll see the sort of similarities and differences to the previous video here. So I'm going to give us an example here, and I'm going to say, what is 4a times 3b? Okay, so here, it's important to note, I think I briefly touched on this in the last video, but when I write something like 4a, this just implies in algebraic shorthand that I have 4 lots of a, or 4 times a. And here I just have 3 times b. Now, let's for a moment consider that a and b were real numbers, that were just any numbers, I don't know, let's say 2 and 6. Well, if these were just normal numbers, we would just multiply 4 by whatever a is, 3 by whatever b is, and then multiply all of these, the two resulting products together. Now, with algebraic multiplication, this works the exact same way. The only difference is a and b here just are a representation of just any number. So the patterns to do with multiplication in regular arithmetic apply in the same way. We just treat these pronumerals, these letters, just as any number, and then we just leave them in the form they're currently in. So if you were to work through this question, well, we have two given numbers here, a 4 and a 3. So we're just going to multiply those as we typically would. So we're going to get left with 12. And then we don't know what a and b are, but 12 is just going to multiply by a, and it's going to multiply by b. So even though we don't know what these numbers actually are, the operation is still the same. What I get with this product up here is just 12 multiplied by a multiplied by b. There was just only one operation that we could work with because we were given the numbers 4 and 3. And that's where we get our 12 from here. So let's try another example. Now let's see what would happen if we had, say, 6cd times, let's go 2c. So this is a little bit of a trickier example. You can see the biggest way this differs from our last one is that we actually have like terms here. We have a 6c and a 2c. Now, how we multiply these is going to change a little bit because multiplication is a different operation to addition and subtraction. So we're going to treat this a little bit differently. So first of all, just with how we did it in the last example, these two numbers, let me pick something that won't give me something similar to the last one. Let's go 3c. So 6 multiplied by 3 is going to give me 18. And I have c multiplied by another c multiplied by d. Now, you can see that I haven't used this shorthand just yet, as I did up here. We're going to get to that, but this is just to take you really slowly through a little step process to see how these numbers all interact. So let's briefly consider this thing here. So we've talked about this before in a previous video. It was to do with squares and powers and things like that. So if you need to refer to that, you can find it on the channel. But when we have any two numbers or any number multiplying by itself as we have here, now we don't know what c is, but we know that the way it's written here, having the same pronumeral, that implies algebraically that this is the same number. So it doesn't matter what c is, but all we know is that it's multiplying by itself here. So anytime we multiply a number by itself, we can think of that as we're squaring the number. So we have another shorthand that we've established earlier. So I can write this as c squared. Now, one more step. Now that I have this, I have 18 multiplied by c squared. I'm using the shorthand again, and that is multiplying by d. And this thing here is my final answer. That is the most simplified way of writing this thing that I have here. So we'll have a go at one more question. I'll try to make this one a little bit trickier, or just more, just give us a little bit more to do, so you can see the extent to which the extent to which we can take this idea of multiplying algebraic terms. So let's go 3. We'll go 7x squared yz times, all right, we'll go 2ax times 3. Let's go 3 y squared z. Okay, so we have a lot of terms here. So I've purposely given us a little bit of a messier example. Let me just chuck a b at the end here, because why not? So first of all, when approaching any algebraic problem, we always want to consider the numbers we're actually given. So in a multiplication here, we're given a 7, we're given a 2, and we're given a 3. The rest of these terms, we're obviously not going to ignore them, but in algebra, we're always looking at these coefficients, these numbers in front of the algebraic terms, because they are going to be the easier ones to deal with, and the rest of the terms are just going to follow the same patterns that we've established in the last few videos. And we can treat these as just any number, but the patterns for multiplying numbers work in the exact same way. So 7 times 2, that gives me 14. And we're going to just work with this portion here, because it doesn't matter which one we multiply first. All we know is that everything is going to be getting multiplied by everything, pretty much, where we're going to do this thing all the way through. So here we have 7 times 2, that gives me 14. Now let's consider some of the like terms here. We have between 7x squared yz and 2ax, we have a common x and nothing else. So here we can consider the x now. So x squared multiplied by x, well, that gives me, in other words, x times x times x, which we can once again write in a shorthand as x cubed. And all of these other terms, we're just going to leave them alone, because the only other thing we know is that they're multiplying by each other. So I can continue my algebraic shorthand, write yza. Okay, cool. So this is so far so good. We're hopefully not in too unfamiliar territory, but we've effectively simplified this entire expression. So we've taken the terms that we know, we've taken 7 and 2, multiplied them together, and we've effectively just multiplied everything else here. And I'm going to now put in my next bit. So I have 3y squared zb. Okay, so what do we do now? Well, we can once again consider the terms here that are just real numbers that we know. We have a 14 and a 3. And when we multiply those together, we're going to get 42. And we can now just as we work through this pretty ugly simplification, we can just take the rest of these terms and we can see which commonalities we have, where we can do some of these little tricks that we did in this previous step, or even here where we could square a number. So we have 14. Oh, sorry, we have 14 times 3 gives us 42. We have an x cubed here, but we don't have an x in the other term. So that's just going to stay. My 42 is still going to multiply with x cubed as we had before. Now we go to our next term. We have a y and we have a y squared here. So y times y squared. That's like once again going y times y times y. And we can write this in our shorthand again. We can go, all right, well, that I can just express as y cubed. Because as we said before, it doesn't matter what y is. Y can be any number. But the pattern we get when we multiply a number by itself 3 times, we can just write it shorthand as that number cubed or a number squared or a number to the power of 4. It doesn't really matter what the number is, as long as by giving the same pronumeral here, so a y and a y, that implies that the number is the same. So we can do this little shorthand trick and give us a cubed here. Now, we're very close. Now, this is a challenge, quite like a challenging problem. So it's okay if we work through it a little slower. We have two z's again. So we can go in and go, okay, we have z times z. I can write that as z squared. And, whoops. And we don't know, well, we don't have any other, we have an a here, but we don't have an a there. So there's nothing special we do there. And we have a b here, but no b there. So these terms are just going to multiply by each other. And we're going to get left with a times b. So effectively, we've reduced this whole thing into products of all of the terms. We have a product of all three numbers, which is 42. We have a product of x's, which is x cubed. We have a product of y's, which is y cubed. We have a product of z's, which gives us z squared. And we just have an a on this side. Let's go this. Whoops. We've got an a on this side, and we've got a b on this side. So these terms are different. So we can just multiply them at the end as we need them. So effectively, with multiplying algebraic terms, we are, in a sense, just like with adding and subtracting, we're taking note of the like terms. That's exactly what I've done up here. And you can see I've color-coded them. I'm considering the like terms and picking up on any relationships with how these interact. So I'm collecting them once again, but instead of adding them or subtracting them, I'm multiplying them here. So the patterns we get when we multiply regular numbers is we can write them in this shorthand thing of x cubed or z squared or so on and so forth. But in essence, we have just completed 3 different questions, all of varying difficulties. But when we multiply algebraic terms, just to sum it up, we take, let me actually write it down. We multiply the known numbers, and effectively we're multiplying everything. Like all of these terms, even in the shorthand as it's written, this is just a product. This is 7 times x squared times y times z times 2 times a times x times 3 times y squared times z times b. So it's exactly the same. It's as regular arithmetic. We're just multiplying everything through. But when we consider algebra, we multiply our known numbers and then we multiply the remaining algebraic terms. And in doing this, we are considering the like terms. So by like terms, once again, I mean like x's or y's. So we have an x on one side, we have an x in another. X is located in another term. Same as y, same as z. So we're collecting the like terms as we would with adding and subtracting, but we're just multiplying these through. And that, in essence, is just a deep dive into how we can go through with our algebraic multiplications. And you can make these questions as crazy as you'd like or as simple as you'd like. But in essence, we're just multiplying through and we're considering these two dot points that I've put at the end here. Thanks so much for watching, guys. I'll catch you in the next one.